Hello my dear students, in this lecture we are going to see one numerical on counterflow heat exchanger. Now in this question we have to find the area required for counterflow heat exchanger. So let us understand the question. The question is light lubricating oil, specific heat of oil is given, is cooled. Now my dear students, let us understand the statement. This oil is cooled means initially this oil is hot, therefore here the hot fluid is oil. Here hot fluid is oil. Therefore all the properties of oil will be for hot fluid. Therefore this Cp is for hot fluid. Therefore specific heat of hot fluid is given 2090 joule per kg Kelvin. Now is cooled by allowing it to exchange energy with water. Now this oil is cooled by allowing energy to exchange with water, means water is a cold fluid. Therefore here whatever may be property given for water is for cold fluid only. Right. Then in a small exchanger, that is heat exchanger, the oil enters and leaves the heat exchanger at 375 and 350 Kelvin. Now here inlet and exit temperatures of oil are given, means it is a hot fluid inlet temperature is 375 Kelvin and the hot fluid exit temperature THO is 350 Kelvin. Then respectively and flows at the rate of 0.5 kg per second, means it is a mass flow rate of hot fluid is given which is 0.5 kg per second. Then water, specific heat of water is given. Now water is a cold fluid, therefore it is a specific heat of cold fluid. Therefore Cp of cold is equal to 4177, it is joule per kg Kelvin. Then water Cp is given at 280 Kelvin is available in sufficient quantity. Now water is at 280 Kelvin, means initial temperature of water means inlet temperature of cold fluid is 280 Kelvin. Right. Is available in sufficient quantity to allow 0.201 kg per second. Now this is the mass flow rate of cold fluid, that is water. Therefore mass flow rate of cold fluid is given 0.201 kg per second. Then is used for cooling purpose. Determine the required heat transfer area for counterflow operation. Overall heat transfer coefficient is 250 watt per meter square Kelvin. Here U is given 250 watt per meter square Kelvin, and they have mentioned determine the heat transfer area. We have to find heat transfer area for counterflow arrangement. So my dear students, here the flow is counterflow. So let us draw the temperature profile of counterflow. Let us say, so here let us draw the temperature profile for counterflow arrangement. Let us say the hot fluid enters from the left side and flows towards right. And during the flow the temperature of hot fluid decreases. Therefore inlet temperature of hot fluid is Thi and hot fluid flows from left to right, and during flow the temperature of hot fluid decreases to the Tho, exit temperature of hot fluid. Now in case of counterflow the arrangement is exactly opposite. That means if hot is flowing from left to right, the cold will flow from right to left. Therefore the cold will enter here, that is Tci is the inlet temperature of cold fluid, and cold fluid is flowing from right to left. Right, this is a cold fluid, and the temperature of exit temperature of cold fluid will be Tco. Right, and my dear students, this left side temperature difference is called delta T1. That is delta T1 is Thi minus Tco, and the right side temperature difference is called delta T2. This temperature difference is delta T2. Right, where delta T2 is Tho minus Tci. Right, and here they are asking what is the heat transfer area. Now my dear students, to calculate this heat transfer we have three formulas. In terms of heat transfer area, overall heat transfer coefficient U, and LMTD, we have one formula, that is Q is equal to UA LMTD, log mean temperature difference. Right, and in terms of this cold fluid we have a formula, that is mCp of cold into temperature change of cold, that is Tco minus Tci. Again in terms of this hot fluid, again we have one formula, that is mCp of hot fluid into temperature change of hot fluid, that is Thi minus Tho. Right. Now my dear students, in this equation if I want to find area, then this U and LMTD must be known, but here overall heat transfer coefficient U is known, but LMTD is unknown. So first we have to calculate LMTD, and then we can calculate by equating this, we can calculate this other parameter, that is area we can calculate. So here I am making sufficient space for the solution. Let us erase the question. We have written everything, all the given data we have written. Now my dear students, we know that the LMTD is nothing but log mean temperature difference. It is calculated as the LMTD will be equal to log mean temperature difference is equal to delta T1 minus delta T2 divided by ln of delta T1 divided by delta T2. This is the formula to find LMTD. Therefore, if I want to calculate this LMTD, I have to calculate all the four temperatures. Here only exit temperature of cold fluid is unknown. So let us equate these other two equations. If I equate these two equations, then I will get exit temperature of cold fluid. Therefore, here this Q is equal to mCp of cold TCO minus TCI is equal to mCp of hot into THI minus THO. Right. So let us put the values. Here in this equation only TCO is unknown. Mass storage, specific heat, inlet and exit temperature for hot fluid and inlet temperature for cold fluid is given. So let us put the values. Now mCp of cold, mass flow rate of cold is here 0.201 into Cp of cold is, here you will find, for cold the data is written here. Cp of cold is 4177 into TCO minus TCI for the cold is 280. Is 280 Kelvin. Right? It is in Kelvin. So will be 280 is equal to, this is equal to, for hot fluid the data is written here. So let us write down data for hot fluid. The mass flow rate is 0.5. Cp is Cp of hot fluid 2090 into THI is 375 minus THO is 350. Right. So my dear students, in this complete equation only TCO is unknown. So let us find this TCO. If I solve for TCO, I will get 311.11 Kelvin. This will be temperature, exit temperature of cold fluid. Now once the TCO is calculated, let us calculate LMTD. Right. Now here I am going to calculate LMTD. Right. Now once the TCO is calculated, let us find the LMTD. Now my dear students, let us write this TCO somewhere. TCO is equal to 311.11 Kelvin, so that we will get more space for the writing. Right. Now let us write in LMTD. Now here LMTD will be equal to LMTD delta T1. Delta T1 is nothing but left side temperature difference, that is THI minus TCO. Let us write it is delta T1 is THI minus TCO minus delta T2. Here delta T2 is right side temperature difference, that is THO minus TCI. It is THO minus TCI divided by ln of delta T1, that is THI minus TCO divided by delta T2, THO minus TCI. Right. This will be formula result of LMTD. So let us put the values. Right. If I put here values, LMTD will be log mean temperature difference will be equal to THI is given 375 minus TCO is just calculated 311.11 minus THO is 350 minus TCI is given 280. Right. Divided by ln of 375 minus 311.11 divided by 360 minus 280. Right. So my dear students, let us find from this LMTD. Right. I will get answer as, so my dear students, this result converts into this result, and this LMTD, simple calculation, LMTD, you will find log mean temperature difference equal to 66.89 degrees Celsius. Right. It will be LMTD. So my dear students, let us use this LMTD formula and use these equations, right, to find area. So here I will use the equations of heat transfer to find area. Right. So let us use the equations. Now this heat transfer is nothing but we can say UA LMTD is also equal to mCp of, if I consider hot fluid, THI minus THO. If I consider cold fluid, it is mCp of cold, TCO minus TCI. Therefore here area will become equal to here mCp of hot into THI and THO divided by U into LMTD. LMTD. So let us put the values. Mass of hot is 0.5, Cp of hot is 2090, temperature difference is 375 minus 350 divided by overall heat transfer coefficient we have calculated 250 and LMTD we have calculated 66.89. Right. So let us solve for area. So my dear students, here area you will find as 1.5629 meters square. This will be your final answer. Thank you dear students. In next lecture we will see one more numerical on this topic.